Good morning, everyone. Today we moving towards the Boolean algebra and some Boolean laws, basic laws. Using of that basic laws, we see there some examples related to Boolean using of Boolean laws. But moving towards first one, Boolean algebra is a deductive mathematical system, may be defined with a set of elements, some set of operators, and a number of unproved postulates. A set of elements is a collection of objects. That is some sort of definitions of Boolean algebra. Boolean system is closed with respect to some binary operator. If for every pair of Boolean values, it produces Boolean results. For example, logical AND is closed in the Boolean system. Boolean system because it accepts Boolean operands and produces only Boolean results. In Boolean algebra, there are laws, some associative, commutative law, identity elements, some inverse, some distributive law. It will be highlighted in details in next step. Boolean algebra, here we taken one example related to umbrella and rainy season and some forecast bad weather. Here we taken one sentence. I will take an umbrella. Have you known umbrella? With me if it is raining or the weather forecast is bad. We see the step one. Here taken or is the high or is the highlighted. Rain, the first one. Here we taken it is and raining or the weather forecast is bad. Means here we taken bad weather forecast. Means rain and bad weather, that is the orange, means the output will be we gets take we have to take the umbrella. This is the necessity because bad weather as well as the rainy season, hence we have to necessity of the umbrella. This is the one for the understanding purpose we taken the example. If this is the one simple proposition. Here we given the sentence proposition may be true or false are functions of other propositions and connected to logical connections, that is and or and not. Basically we in Boolean algebra we learning the basic laws, that is and or not. Already we know about that all that laws. We seen already details in and or not all that things. Here we taken the truth table. Same sentence. I will take an umbrella with me if it is raining or the weather forecast is raining. It is the one column. Bad forecast is the second column, and our output is the umbrella. For example, no rain, no any forecast weather bad. In that case, no necessity of umbrella. Hence, we are taking here false. Rain is the no rain, bad weather. In that case, we have to necessity of umbrella because here is the bad weather. Rain is the present, bad weather is the not. Then also we required umbrella because raining is the going on. Same rain will be and bad weather is there. In that case, we have to necessity of umbrella. Means when rain and bad weather will be absent, in that case not necessity of umbrella. Means when you go to the 0 and 0, in that case It is not necessity to umbrella means we have to take here 0. Remaining times we have to require to take 1. Boolean algebra. The why name will be given Boolean algebra because the George Boole, the scientist, mathematician, then developed that Boolean algebra for the simplification and handling some complex connections and using of some Boolean algebras, Boolean laws, we have to reduce the equations. In Boolean algebra, it uses some ordinary algebraic notations and 1 for true and 0 for false. Here we taken another one example. Same example, but we change the gate. Raining is the going on, bad weather is the umbrella is sorry. We prepare the one truth table for the previous condition for the or purpose. Same, we putting the value 0 0 we get the 0, 0 1 we get 1, 1 0 we get 1, 1 1 we get the, that is the U means umbrella, R means the raining, that is the plus sign indicates the orange and F is the bad. Means that plus it is the notation of Boolean equation. Now we go to the next sentence. If I do not take the car, then I will take an umbrella. If it is raining or the weather forecast is bad. Here we adding the another not get, and that or and not get we connected to the ending purpose, and what will be the output will be see the stepwise. Or what will be our sentence will be saying here, I will take an umbrella if it is raining, rain is the input or weather is the bad, means this is the inputs for the OR gate. Whatever the output will be given to the AND gate. And what will be the first sentence? If I do not take the car, that is the not, means car not taken, that will be given to the AND, means this is the not, means ring and not be given, the output will be you have to take the umbrella, means that not it is the given the negative notification, that is not necessary to take car, and that not and rain and bad forecast we ending with each other, and we got the solution, that is the necessity of umbrella, that is the C means we are taken your car, it is the that sign will be indicates, that is the complement sign, means not get sign, otherwise we are also calling the complement, and that dot will be indicates the AND gate sign, and that is the already we seen plus sign will be indicates the OR gate sign, that W means bad weather, R means raining. This is the given some arrow indications, not, AND gate and OR gate. Here we did some taken basic Boolean identities. This is some Boolean laws. This is some fixed laws, that using of these laws we have to reduce the some equations. Check the stepwise. X plus 0, that is the plus means it is a OR sign, is equal to x. Same for the x and 0, we get the 0. Same x ORing 1, 1, x ending 1, x. X plus x, we get the x. This here is the double identity, we take only one. X into x, we also take the 1x. X plus x complement, this is the 7 number law, we have to take 1. x into x complement, that is the 0. We are calling here into, that is a AND gate, otherwise x multiply x complement also we are calling. Ninth law, x plus y is equal to, that is the y plus x. Another one, x y equal to y x. 11 number law, that is says that x plus in bracket y plus z equal to, here some laws will be going on. It will be see in detail in next slide. That is the equal to x plus y plus z. That is the laws given in details. We see the in details. See here the details. Here is given the details laws. The necessity of that laws are very important to reduce the equations. This is the some basic laws. Here we take and draw the one tree diagram. Some Boolean algebras laws, commutative law, associative, distributive law, identity law, idempotent law, double negation law. The commutative law, a binary operator on a set is said to be commutative. The associative law, the binary operator on a set is said to be associative. Same, the laws will be given for the ORing purpose and adding purpose. In commutative is here, A or B is equal to B or A, and A and B equal to B and A. Same associative law for the and or purpose. Distributive law. Identity law, it is the basic law, A plus 0, that is a some base equal to A not 1, sorry, A into 1 equal to 1. Idempotent laws, that is the A plus A, that is the A and A multiply A, that is A. Double negation law means A double bar, in that case you have to take the only A. Means this is the some negation laws by using of NOT gates. Previously we seen the some laws. After that laws we have to necessity to learn De Morgan law as well as De Morgan theorem also. Here we taken in graphical representation of De Morgan law. That is the two inputs A and B, and after that connections we connected the NOT gate. Yes, we taken here a bar. The De Morgan's theorem is say that AB bar is equal to A bar plus B bar, and we have to simplify the equations by, here we given in details. AB bar is the, this is the logical diagram will be given here, and we have to simplify the AB bar logical diagram is equal to A bar plus B bar. Yes, the input of A and B connected the NOT gate. Hence A will be, that is the true value after connected NOT gate, that will be gets the A bar, and here is the plus sign means you have to require OR gate. Same for the B bar. Means A bar, B bar, here is the input of A bar, and here is the input of B bar. That will be connected to the output. That will be gets the A bar plus B. The NAND gate is an equivalent to inversion followed by an OR gate. This is the first De Morgan theorem. Second De Morgan theorem is the, here we take an ORing. The A and B is the input given to the OR gate, but A plus B bar whole bar is the given is equal to second De Morgan A bar into B bar. Means ORing we have to connect with ANDing, that A plus B whole bar, that is connected with NOT gate, hence we get the A plus B bar, and after that A and B is the true values will be connected to the NOT gate. Obviously A will be gets A bar, B will be gets B bar. In that A bar, B bar will be connected to the AND gate. We get the A bar, B bar. Here we given NOR gate is an equivalent to an inversion followed by an AND gate. Here we check the some Boolean laws and identities. Here we taken the some reduction example. Reduce the Boolean expression function xyz plus x bar y plus xyz bar is the given equation we have to reduce. Here we using the distributive and commutative law. Xy it is the common term in given equation. Hence we take on the outside. We prepare the one bracket z plus that is the z and z bar. That is the xy it is the common and the remaining x bar and y bar is putting as it is. After that z plus z bar and x bar that is some identities laws already seen in previous. Hence that the till becomes as an 1. Hence the we gets the answer is the as an idea using of identity laws. The answer will become. We also check in previous. Here we give an identity law. Using of that identity law, we get the answer 1. That is the z plus z bar we get the 1. Hence what will be remain xy plus x bar y. Then we here we get the y is the common by using of distributive law. Y we takes the outside. We get the bracket x plus y. Again identity law we are applying here. And we get the 1 and what will be remain that y and our answer is y. This is the some simple reduction by using of identity law, distributive law and commutative laws and we got the answer. Means this is our equation. After reduction we got the answer y. Hence it is a very necessity to learn the Boolean laws. Another some advanced Boolean laws we have to require to learn because this is a necessity to produce some examples. Some this is the advanced laws you have to note on your notebook also. That is the x plus xy we get xy sorry xy plus xy bar that is the x. This is the some advanced Boolean laws. It is also necessary to use in different equations. Here we take one example. That is in bracket a plus b, second bracket a plus c. We have to reduce that equation. Simple. We have to multiply with each term. We multiply a into a. That is a c, a b, and b c. This is a simple multiplication. After that, you check the any common term will be that is the a means this is the double term. Hence, there is the omit and repeated terms. We have to take only one term. That is the AC, AB, and BC. After that, in second equation, A is the common term in three variables. Hence, we take an A outside. That is the A. Means here is there no term means 1 C plus B plus BC remaining term. That is the here as we are using identity law. That is the one term. Hence A plus BC. This is our final answer. This is the equation and we reduce that equation. In last we seen the min terms and max terms by some SOP and we prepared non SOP we prepared standard SOP form. Here we take an given example simplification example. ABC equal to summation 1 4 5 6 7 in min term expression. Then we for the one purpose we taken the equation a bar b bar c. That is the a bar and b bar is in min term we are taken 0. C is the present term 1. Here a b c is the given terms, means the all the variables up to the 0 to 7. Next one 4 variable means b bar and c bar is the 0. 8 is the means 4 to 1, that is the a is the present. Same for 5 and c is the present, means 4 and 1. 6 a and b is the present. 7 all the terms are there. And we taken this equation for the reducing purpose and simplify the equation. That equation, last 4 terms there is a is the common, means we taken a outside of the bracket. After that remaining 4 terms, b bar also some common and b also common, means c bar plus c gets some 1 here also, means we got the b bar plus b. This is the some identities law, and we got the equation a bar b bar c plus a b bar plus b. This also identity law, hence we got the equation a bar b bar c plus a. In this term also a and a bar will be taken as an a by the using of law, basic laws. We got the equation b bar c plus a. This is the three laterals compared the given equation. This is a simplification. Here we taken some 4 to 5 6 examples to see the stepwise. The example of the first one, the given equation ABC plus ABC bar plus A bar BC plus A bar B. Here we taken the common terms AB, we get the C plus C bar, and next equation also we get the A bar B common, then we get the C plus 1. That identity law will be applied, hence we taken as it is AB. Here also we get the 1 identity by the OR law A bar B, means we got the equation AB plus A bar B. B will be gets common, A plus A bar, that is the identity law again, hence we got the as it is term, that is the B. This is the simplified equation. Same here we taken the A B C whole bar plus A bar B C plus A C bar. Here we applying the De Morgan's theorem. De Morgan's theorem means we get the ending with the ORing by the equation. After that De Morgan we taken as an a bar plus a bar, we putting as it is, and here we taken using commutative law, and after that we using of identity law and factoring all that conditions, and we got the one reducing equation. Same you check the equations and we got the solution by the we given here stepwise by which law will be here using. I think all of you cleared all that concept, and after practicing then and then we go remember that all those laws. This is the not that much examples necessity to solve the Boolean law. This is the given. I will take the examples in your assignment as well as in tutorial sessions. But you check the stepwise which law will be. Then when you are doing the practice, then and then you will get the remember all that laws. Okay, thank you. Thank you.